everyone, my name's John Grimsmo and this is another Knife Making Tuesday. So, remember back around week 53 I think it was, must have been just over a year ago, November 2012. I had this video where I designed a new knife in CAD and I sort of fly through the whole CAD program and just design this knife from scratch in the video and show how I do it and all that. It was a pretty cool video, very well received amongst everybody. A lot of people love the design, they want one and everything, but it's a tricky design, so I haven't been able to really do much with it yet, until a new friend said, how would I hook you up with a prototype of that knife? What? Yeah. He 3D printed me a prototype, exactly to my CAD specs. Of this is my 3-inch integral knife. Integral because the handle is one solid piece of titanium, or in this case plastic, but it will be a solid titanium handle. So for now I'm just calling it the 3-inch integral, and I've got a few other names for it, but nothing's stuck yet. Anyway, if you don't know anything about 3D printing, go to Google Images right now and search 3D printing and you'll see a billion results. It's a very cool prototyping CNC machine basically that prints parts in plastic. You can print anything. You can print the weirdest, most complex shapes because you're not constrained to the 3 axes of milling and where you got a tool and you got to reach it and all that stuff. 3D printing just prints it layer by layer by layer by layer by layer. You can print a perfect sphere that's hollow inside. You can print pretty much anything. So when he said he would print this for me, I was ecstatic and I was like, yes, let's do it. And I've had it for a few months now. I've been meaning to do this video. It's finally time to do it. So let's take it to the bench and take a little closer look. So this is my buddy Jake. All of his information is right there. I'm not sure if he has a website yet or not, but you can always call him or email him and bug him. He does prototyping work. Nice band-aid. He does prototyping work. This card is actually 3D printed. You can see, if you look really close, you can see the grid pattern. You can see the 2 different colors of material, unless this is also black and it's just one layer thick. Can't tell, but I mean, if we look really close, you can actually see the lines around the J where the filaments were deposited. It's really cool stuff. And Jake's been a really nice guy and a good friend. So what he did is I sent him 3 CAD files, my blade, my handle, and my stop pin here. I'm using an actual pivot pin from one of my Norseman knives and a set of bearings that I have. Otherwise, this is completely 3D printed. And my stop pin likes to fall out. However, this is the lock bar, which is supposed to be right there. It broke off on about the 3rd day because this might be strong enough in titanium, but it's not strong enough in plastic. And obviously I realize that now. So were I to do it again, I probably wouldn't make this section thinner like you would on titanium. I would just leave it solid. Anyway, I'm going to have to look up which printers he used to print the blade and the handles. If I figure it out, I'll annotate it on the bottom. Because he's got like 3 or 4 different 3D printers, some quality ones. I know he's got a MakerBot, some resin printers. I forget what he used for these, but I know he told me, so I'll put it in. But there are 2 different styles of printers. This blade is printed very high resolution, except it's a really weird material. It's kind of rubbery, and I think it's plastic, but it's very rubbery. It's kind of cool, actually. And the handle, whereas the handle is very solid plastic. The other thing you can do with 3D printing is you can make things hollow. So like this handle, just this side of the handle to the top is currently solid. but you could put a lattice structure inside this top handle to make it hollow basically, and make it a lot lighter, but also reduce the printing time considerably because it's just depositing less plastic. So for a non-structural part, you could make a lot of this hollowed out and it would print many, many times faster. So I've never had a prototype 3D printed before. I've kind of always wanted to get a 3D printer, but you know, they start at, you could probably get one for $500 and up, you know, up to like $5,000 for starting to get really nice. And I've never had the budget for that at the moment because I don't need it so much. And when I got friends like this that can print stuff up for me for a small fee, I mean, it's totally worth it. I don't need to get my own printer and kind of spend the time it takes to learn that and do all that. So, but like I said, I've never gotten the 3D printed part before, and I'm super stoked at how this turned out because it allowed me to see and feel the knife. I mean, what it's going to be like when it's an actual metal. Like, hold it in my hand and flip it. And, you know, feel the jimping that I put here, if that's in a good place. Just how it feels in the hand, how it would feel to cut with. It's an amazing process. And I'm so glad that I got it done. I can't wait to print another one just to do it. I mean, Jake says he prints at least 1 or 2 copies of whatever he's making before he machines it. He's also got a Tormac. Just because it's easy. I mean, 3D printing, I believe, is really easy to code, and then you just hit go and it prints, and it takes, you know, 5-10 hours, whatever it takes, and your part's done. You don't have to do anything. It's not like machining where you have to watch the end mill every second, you know, on the first run just to make sure it doesn't break. But yeah, what else can I say about this awesome thing? Like I said, the stop pin keeps falling out. He also printed this with that kind of rubbery resin printer. I had him print the threads up at the top, but the resolution is almost good enough on this part, yet in the plastic it's not good enough, so obviously it doesn't thread in, it just kind of pushes in. But it does function as a stop pin, I mean, open and closed. So yeah, one kind of cool thing I like is that because, drop my stop pin again, because of the way the printer prints layer by layer by layer, it makes the blade have these horizontal lines just like my Norseman knives, because I machine them layer by layer by layer. So this is actually kind of a good preview of what the blade will look like if I choose to machine it, which of course I will, but if I choose not to grind them out. I kind of like it. So, side-by-side comparison, this is my personal beater Norseman. You can see it's quite a bit smaller. I wanted to make a small gentleman's kind of knife with a 3-inch blade. 3-inch only to conform to some laws, but just because I wanted a smaller knife. So yeah, it's noticeably smaller. There's no lanyard hole like there is on the Norseman, so the blade, I stuffed as much blade in there as I possibly could. You know, there's hardly anything left over there. Whereas on the Norseman, you can see the tip of the blade here, I have to clear that lanyard hole. There's a good, easily a 1/4 inch, maybe more, of kind of wasted handle, except for the lanyard. A lot of people like the lanyard. I don't use it, so I wanted to make a knife that didn't have it. But I mean, the profile is so much slimmer, and it's going to be just a joy to carry and to make it. Thickness is a tiny bit thicker, although my inlay knife here is thicker because of the inlays, so they're probably about comparable. But like I've got another brand new one here without inlays, and I think the integral will be a little bit thicker. another example of an integral is, this is a Peter Recenti. I forget which model this is. I'm not too familiar with all of his models because he's got a ton of awesome ones. But this is an in-progress integral frame, one of the early ones that he did. And there's something wrong with it, probably here or something. So he just gave it to me. And it's kind of cool to just have around and play with. But this started out as one solid chunk of 5/8 titanium. And then it was milled out, you know, drilled and whatever, and then a slitting saw comes in and carves out the channel there. Or, actually, this wasn't done with the slitting saw. Let's see if I can... Okay, this isn't a great example of an end mill, but this was done with an end mill, holding upright, and it just goes down pass by pass by pass and carves and carves and carves and carves and carves. That's one way to do it. It's a very common way to do it. The thing I don't like about that is because you need a very small end mill with a very long length of cut, which introduces a lot of deflection and vibration. And you know, it's one thing when his his gap here is, this is a 3/16 end mill and it fits in there, so they probably used the 3/16. My gap is going to be 5/32, which that don't fit in there. So I need to use like an 1/8 inch end mill pretty much. And an 1/8 inch end mill with like a 1 inch length of cut, that is a huge end mill. Hence why I like the slitting saw idea, which is one of these. This is a brazed carbide tip slitting saw I got from Lakeshore Carbide over a year ago. And the theory is that you hold the handle like in a vise or in some sort of fancy fixture like this, and then the slitting saw just comes in and carves out pass by pass by pass by pass by pass until it gets all the way in there. Now I'm starting to realize that the diameter of this one, I think it's a 3-inch saw, it might not actually be enough to get inside my handle deep enough, because the arbor has to go around here and take up room, so I might have to get a 4-inch version of this as well to make this work. But yeah, that's the slitting saw, and very much looking forward to trying that. So like I said, the coolest aspect of getting something 3D printed is feeling it in your hand, and you get to see what you like and don't like about it. You know, there's things I thought in the CAD program were perfect and were good, but then I get this and I find out that they're useless. For example, this is my lock bar. You know, it goes right in there, and this is what keeps the blade open. If you'll notice, it's very narrow and very long, whereas on the Norseman it's not quite twice as wide, but almost twice as wide. You know, 1.5 anyway, and about the same length, I guess, but that just makes this width to the length very long and very weak. It could be very flimsy. Obviously I will dictate the thickness that I leave it at, and that depends on how bendy it is. But when it's so thin and so long, it has a tendency to go like this, because it can bend that way because there's not a lot of meat to keep it in. So I'm gonna have to redesign it so that this width is thicker, which will be good. I didn't know that. Another thing I realized is that before this broke off, this was pretty obvious. So when the blade's in the open position, the lock bar goes there. You disengage it and you start closing the blade, and just because of the tight tolerances, the lock bar would actually fall into this groove right here when the blade's halfway closed, and then it would bind up. So this wouldn't work in a real world knife, because the lock bar would spring over here, so it'd be dumb. So I'm going to have to change something to get that to work. But I didn't see that until I had a physical 3D printed model in my hand. So I tried to make all the lines like blend together and tried to give it this cool, you know, angled look there with the hump there. Inspired a lot of inspiration from GTC. My friend in Brazil, Gustavo. And also Benchmade 940. Quite a bit bigger, even though it doesn't seem like it'd be bigger. But you can see the handles are sort of inspired. These cutouts, you know, I've got the same thing going here and here. Sort of inspired by that. So yeah, another thing that might be kind of weird is to make all the tolerances and distances work and everything. You can see on the Norseman the flipper lever is about even with the pivot, and that gives you a certain amount of leverage down. On the Integral I put it quite a bit higher, which it'll be interesting to try it on a knife that's fully assembled. But what I'm finding is, you know, I put this little jimping there. What I'm finding is my finger is actually rolling up here onto the lock face, and that wasn't intended. You know, I thought you'd be right on the jimping here and flip it, but you're not. You end up rolling up onto the lock face, and it feels kind of weird, so I don't know how that's going to work on the real knife. But my point, you know, the point of doing it like that is because I wanted flipper lever visible here, but not visible in the open position because it's hidden by these little wings right here. And I thought that would be kind of cool, is to have a hidden flipper when the knife is open. But conversely, they look and feel kind of dumb when the knife is closed because they're right up there. And I don't know if I like that. If these were titanium, they'd be kind of sharp and annoying, and you know, it might abrade something, and I don't love that. So I might chop those off or something. We'll see. Don't know what to do for a pocket clip yet. I've suggested just using my Norseman pocket clip, but guys like Brad Southard are saying, no, you gotta make something that's different, something that fits this knife better. So I might just do that. However, overall, I freaking love it, and it's going to be a lot of fun and really nice and small to carry. And it's going to be a good challenge to machine it because the slitting saw cutting it out, and if you'll notice the whole handle is contoured this way, whereas my Norsemans are flat, which means since it's going to start out like this, then the whole thing is going to be 3D machined using a ball end mill, back and forth and back and forth and back and forth to get this archy pattern, and then flip it over and do the same to the other side. So it's going to take a long time to machine, but it's going to look really sweet when it's all done, and it's going to be epic. So as of yet, I have no idea on time frame. I'm not taking any pre-orders. If you want to know what's happening, you can always just ask me, but keep an eye on the videos and sign up to the newsletter on my website, Grimsmo Knives. But I doubt I'll be selling these for at least 4 to 6 months, at least. Let's call it 6 months minimum. I don't know. I just need the time to actually make a prototype and see what's going to work. But yeah. And I dropped it. So that'll conclude that video. Thanks for watching. Bye.